In this video, I'm going to explain what a moment is. And to give you the answer straight away, the expectation of x, that's your first moment. The expectation of x squared, that's your second moment. In general, the expectation of x to the power of k, that is your kth moment. This is exactly the definition of a moment. Now, the next question is, okay, well, how can I evaluate my moments? You might recall that your expectation of x, that's simply mu, and we can find the expectation of x squared using this relationship right here, that the variance of x is the expectation of x squared minus the expectation of x complete squared. So if I make this a subjective formula, I get the expectation of x squared is equal to the variance of x plus mu squared. But what if you don't know mu? What if you don't have the variance, and what if you just want to find some other value? If you want to find the expectation of x to the power k for a value of k greater than 2, what can you do? Well, this is where our distributions come into play. So recall that the expectation of x can be computed in two ways. It depends on whether x is a discrete random variable or whether it is a continuous random variable. If x is discrete, then the expectation of x is simply the sum for all x's of x taking on a particular value times the probability of that value, where this is your probability mass function, PMF. So note that this terminology, probability mass function, is only used when x is a discrete random variable. If I have a continuous random variable, then my formula would be the expectation of x is equal to the integration from negative infinity to infinity x times function x of x dx, where this right here is your probability density function, or your PDF. So again, density is used when you have a continuous random variable. Now, everything else is quite straightforward. If I want to find the expectation of x squared, I just replace x here with x squared. So it'll be, assuming that x is a continuous random variable, negative infinity to infinity, x squared times function x of x dx. So in general, the expectation of x to the k will equal negative infinity to infinity, x to the k times function x of x dx.